divided by 4. Does that make sense? This is the thing. Rate of the
Okay,
rate.
yeah, I guess.
Divided by 3 again. So which means 1 over 12 is for each converter
Oh,
for a
so then
day,
it's
right?
like wait, so this is like the rate, so it's like one bed per one. Okay,
Yes.
so
Yes.
over like x plus 1 over 12.
Yeah, exactly. Yeah.
X equals 6. Oh, okay. So like how does like the rate work?
Rate of the rate. It's called rate. Normally 1 over 4 is the rate, right? But they also happen to tell it's in 3 days, so you have to divide it again. So it's called rate of the rate problem. You can say rate of the rate, which means you have to divide it twice to find the specific fundamental rate. Does it make sense? Rate of the rate. Rate is 1 over 4, but you have to rate again, so divide it by 3 again.
Is like the formula for rate like 1 over, so it's like
Yeah, it's kind of
just
like a
like
formula.
one
It just,
thing built
yes,
over.
yes, yes, yes. It's kind of like a, so the key is how one person, how much one person build for one day, it's certain. Its rate is certain, right? Does that make sense? How much one person do for one day, it's certain. So that's why you have this ratio. Does that make sense?
Yeah, yeah, because like it's going to be like one bed regard and going to take
Yes,
the
yes.
same
So basically
energy.
yes. So basically every time you just, well, it's just a normal kind of like, if you want to say the general formula is just distance divided by time. Does that make sense? You divide it by 3 person, it's basically the same thing. Does that make sense? Just per one carboner here. Does that make sense? So that's why I call it, on some level, we can call it the rate of the rate problem. Does it make sense? You have to divide twice. Is that okay?
Distance over time, so it's like
Yeah,
bed
one
over
bed
time.
over 3 days, but it's just 4 carboner. I want to say per one carboner, so I had to divide it by 4 again. Does that make sense? Of course, my distance is just one bed. The things that I finished, or like the distance I finished. This time is the thing that I finished, which is one bed. So that's why I use it 1. Oh, you also have to be careful. This kind of thing we like to use 1 a lot, right? Does that make sense? If there's a one bed, we say it's 1.
Yeah, that makes sense. 1 over. Yeah, I just didn't know that like it could be like 1 over like carpenters, you know. It's like
Yeah, otherwise the converter thing is a little messy. There's other ways, but this way is because the common one is you to find 1 over 4. This is my speed, right? But that my speed for 4 converter. So they talk about how many converters, so it's not certain. So I had to divide it by 4 again. You can think of like this. It's also the same. Just you have to divide it by that thing twice. Does it make sense?
yeah, you divide it twice.
Yeah. If you want a formula for this, it could be something like this. The distance or whatever accomplishment that you did, which is a bet, divided by the time and divided by how many people you have. If you really want the formula is this.
Okay, yeah, that makes sense.
Mm.
Yeah, so I just didn't know like the formula was the same. I was like I was confused.
Yeah, we're all confused. First, we don't know this one could also be counted as 1. And then we have to divide it. So the key is the rate is the same, right? We find that rate by 2 conditions, and they're the same. The rate for
Yeah.
one person, how much one person build for one day. Okay, next
Yeah, yeah, I
one.
understand. Like, could we move on?
Next one is what? This 22 is the one that you have question mark?
Yeah, 22.
Let me see what you did. You got stuck, right?
Yeah, because it's like there's like two different constants. Like, how am I supposed to find what like the numerical value of C is? If it's like 1 over C and x over 77, I don't, and plus 1 over C, and I don't know what x over Z is.
Yeah. There's one hidden information. First is
It's like the exactly one solution, but I don't remember what that means for like the equation.
Normally, when have this, there are two kinds of situations. Let's do situation one. This is talking about b squared minus 4ac discriminant. Do you remember this?
Wait, yeah, 4b² minus, that's the solution?
Yeah, that's
Oh
for
wow, I forgot.
quadratic equation, right?
Oh yeah, that makes sense. That makes more sense. Yeah.
Yeah, this is
So that
connected a little bit, right?
I just forgot that bit.
Yeah. It's a different section in like SAT and in pre-calculus. So anyway, but this one requires a quadratic equation. This is not a quadratic equation, right? Then that's a bummer. But
Oh yeah.
we have not simplified this enough. Does that mean that we don't want to deal with fraction, right? We get fractions, we want to get rid of the denominator, right?
Yeah.
So let's get rid of the denominator, see whether I can have a quadratic equation or not. If not, we have other method. So let's just times cx, right? That's
Would it be times CZ?
wait, is that z? I think it's x.
Isn't that a Z? That's why I was so confused because there's a Z and also an X. Looks like a Z.
Yeah. Well, it's x.
Okay, sorry. It's very blurry. It looks like a Z.
Yeah.
So that's why I was confused because there's like two different like variables in the equation. It's like really.
Yeah, that'd be bad. I'm familiar with. So that's anyway. I times cx, including 76. So 76 cx, right? If I time that, that would be 76, right? And that one would be 76 cancel.
That would be like
cx squared.
CX to the power of 2.
Yeah, and
Plus
plus
76.
76x, right? See, that's exactly a quadratic formula, right? cx squared plus 76x minus 76, right? Equals to 0. And I want that to be b squared minus 4ac to be 0, right? Now I can use it, right? Does that make sense?
Yeah.
So that'll be 76 squared minus 4 times a, which that a is that c, right? Here
Yeah.
we see
Times C
c
times
times,
negative 76.
yes, negative 76. Yes, negative 76. And then that should be 0, right? Exactly one solution is discriminating being 0, right?
Wait, the discriminant is 0?
Yeah.
Why?
Do you remember that for the discriminant data or b squared minus 4ac, if you are 0, do you have one and only
Oh,
one
yeah, so you only
solution?
have one solution. Right,
Yeah.
right. That makes sense. Okay.
And true is the other situation is if they are greater than 0, you have two, right? There's two different
Yeah,
solutions,
yeah.
right?
And if it's less than 0, there's no solution.
0 solution. Yes.
Sorry, I just forgot. I forgot this has been a while.
Yeah.
And then basically just solve. Yeah, you like. Let me do like pull up like a calculator.
Oh, I think you can simplify. There's 76, but that's okay. Same thing.
Oh, okay, yeah, I see. I think part of the reason why I got it wrong was because I read 1 over CX as CZ because it looks it's very blurry.
Yeah. Sorry for that. Because I didn't do this as the student did this for me. So it just, well, when of medical school is can't be it. So anyway, is that making sense?
Yeah, that makes sense. That makes a lot of sense. I'm glad I like could review like the minus B, like like the solution thing.
Yeah. So first thing we have to I just kind of translate. Every time you see exactly one solution, you think about d squared minus 5c equals 0. This is not all the time, but say 80 or 90% of the chances. Does that make sense? This is discriminant, right? And then B, true, is we have to, making it a quadratic, which means we hate fraction, right? Kind of, in a way that we hate fraction, right? If we can simplify it, we make it into, well, at least not
Yeah,
no
yeah. No,
denominator,
yeah,
right?
I understand. I just kind of forgot them like the principles. Like
Yeah, okay. Next one. What's the next one? Okay. You also mark the one next to this also question mark, right?
yeah, 3. When I circle something, it's like
Okay, that's the one. K and T are positive constant. A solution to this is this.
like the same sort of thing was like when I thought it was like Z and X, because it's like how am I supposed to know what the solution is? Like how like it's like two, there's like three, that there's like two different like variables, and like there is barely like any like actual like numbers, just like a lot of, well, actually just like two constants and one variable, and it's like I don't know, it's kind of,
Okay. So can I just simplify this first? Of course, I can
yeah.
expand that, but normally I find finite angle, I can simplify it, which means that there's common factor. You see that?
Yeah, I do see that. Oh, we could just divide, wait, hang on, we could just divide like it by,
Get a common factor, right?
we could just do this. Oh, okay, yeah.
And
I kind of forgot.
7x plus t minus 1, right?
Oh, wait. Okay, I get it now. So I just spin them. Oh, wait, I understand now.
Uh, uh,
Sorry, I think I just got confused because of like the constants, and then I kind of forgot to act.
yeah, this is
I don't
one
know.
type of question. It's like the College Board want to make some messy. It's not very obvious that you can't really, well, make a pattern out of this. Does that make sense? Either the first thing is we simplify, or the other questions that you don't really have any solutions, you just have to expand it. Does that make sense? There are other questions too. You just have to expand that, if nothing else,
Yeah,
and
sorry,
see.
I was kind of being stupid. I just got it like really.
Yeah, if you want Excel, so I did once to try to expand it without thinking, that fall into the trap. Okay,
Yeah, I
next
think I
one.
was trying to expand it too, as far as I remember. I don't really know.
Yeah, you
Just-
expanded it, and there is some question we really have to expand it to do it. But for this, we do like a factorization first, right? That's why we learn
Yeah, I think I should.
factorization.
Yeah, I think I should have thought of like the obvious route. Uh,
Hmm.
Next one, I guess.
Find the
Sorry,
easy.
that
Yeah,
was kind of stupid. Well, whatever. At least I got it.
yeah. So next one. Next circle problem is the here.
It's Oh, sorry. I didn't realize this was so blurry. It's
It's
like
okay. This one.
20,
Oh, this one. I know this one. I remember this question.
40. I don't know.
So
They're all in
many.
such a weird order.
34, that factorization thing. Go to that 34. Yeah, this one. What's your answer for this?
I just had some like I just had some trouble like figuring out
There's
like
yeah, where to go about this. Just take a look. This
I
is the
actually think I
thing.
did.
Yeah.
Oh, okay. I was gonna say I actually think I did a similar question later.
Yeah,
Let me try
yeah.
to figure. Yeah, and I
There is
also
a
got
similar
that one
question.
wrong. I didn't come back for this, but I think like after getting to formula sheet, I understood a bunch of things better. Let me just try doing this right now.
Okay.
So like, hopefully it's not like a situation like last time where it's like, Yeah.
Oh, you know how to do it, right?
Yeah, I know how to do it now.
Yeah,
I
just
think I'm
try.
just overthinking like the Q and R thing.
Yeah. Did it
Is
on
that supposed to
purpose.
like mean, is that supposed to mean anything, or is it just like a distraction?
Distraction. They just want to make so many variables so that you don't think. And they want you to,
Yeah, I think I was just overthinking like because there's like different variables involved, so that's why I was like kind of confused. But now like
they
after
must,
doing another one of them, like I think I understand.
yeah, they must have shortcut when they have so many variables. Z, Z to the next power is just kind of like X, right? You can simplify to change it into X or T. Yeah, it'll be easier.
Yeah,
And then it's
yeah.
just combination, right? Combination
Yeah,
is
like I
which
said.
one times which one. This one is okay then. Let's see. 18 is that the a to the x power? I remember that question. Let me just go for it. Okay, this is still, oh, this is also similar. You get stuck this because all this they can't solve perfectly as we normally did. Does that make sense? For this one too. Too many variables. That's confused us, right?
Yeah, I just it's like I think I got better at them like later on, but I feel like for some of the variable questions, it's like it just kind of confused me like there were when there were a lot of them. It's like
It's just kind of like a when it's getting really evil, you just have to have faith. Just list it all together. You must can
you just
you
have to
definitely
simplify. There's like a
yeah
shortcut
yeah you
somehow.
simplify.
You
Eventually
just
you'll
have to
see
get
the
rid
light.
of some of them.
Yeah, the highest level of difficulty is limited, so it won't be that difficult. So
Yeah,
anyway,
I think some of the later ones I figured it out. I think on the first few I was kind of rushing.
uh,
I should have kind of gone back to like look more at those.
right. So well, we don't have anything else. Since this is the function, it is a this is the point. I said, well, substitution is the first thing, right? A to c's power minus b is 7, right?
Yeah.
And then is a to 2c power, right? Minus b is 117, right? Those are two things we
Yeah.
get from there, right? And they kind of look like a what system of equation, but not
Yeah.
so far because we have too many variables, right?
Yeah, there's just like there's just like a lot of variables.
Yeah,
So you
but
need to like
there's a little pattern in here because normal way that can't solve this. They must have something that we can have a little connection. What's the b? It's just a normal b, right? Nothing else.
yeah.
But this a to c's power, and here this a to 2c's power. Does that ring a bell?
Oh yeah, yeah. It's like we can substitute like x equals
Yeah.
a.
Yes, that's
So
nice. Yes, good.
so it's like x.
Yes. Yeah, very nice.
Oh wait, wrong. Oh. Does it ever say if a is positive? Okay, so x equals 11. Okay, 11 minus b equals 7. B could be 4.
Yeah, sure.
It could also be like
What's the other one?
wait, okay.
Yeah, negative 17, right?
Negative 17, but there is 17, but not negative 17.
Yes, that's good, right? Because we're supposed to define what, otherwise we have to make a distinction, right?
Yeah.
So A it is, right?
Yep.
So this one and the last one, they both have. Last one is that x 9
It's
power
just like
and
the
x
it's just like
18.
substitution. I think I was overthinking like
substitution.
the
So when they have too many variables, substitution, or they must have something to tell us that we can use. Sometimes they also tell us something about like that integer or something, right? And that we can also just try it out, or smallest integer or some sort. Okay, let's see. That's 18. This next question is. This is a no circle. Oh, here's a circle.
Sorry, I didn't realize it was so blurry when like
It's okay. 0.
829. Oh, I remember this.
829. Okay, let me go there. 829.
It's like 15, but like these are just in such a weird order.
Yeah, it's in all kinds. It
Oh
basically
yeah,
covers
that one.
that one. It covers all SAT. Not the latest one. Yeah. The function z is defined by the equation, and the value of zw decreased by p%. For each increase by 1 in the value of w, which of the following is closer to the value of p. Let's just translate this second sentence into something that we're familiar. For example, it said decrease by p%. So there must be something like a kind of, you have to time a 1 plus p, right? Kind of thing. The thing is,
1 minus p.
right? Right? And then they said every increase by w, and I'm gonna increase by p%. Oh, that's a bummer. It's because what? Because what they gave us, there's a true, it's not a direct way, right? For example, the normal things that I would like is just are you familiar? You're familiar with the exponential function, right? We use a b to x power. Do you remember the definition for this kind? If I increase x by 1, that's what they say, right? Increase x by 1, and then b, it's increase or decrease by a factor of like b, right? The whole thing. Does that make sense?
Sorry, could you repeat that? B increase or decrease by a factor of what?
Like actually not b, fx. Saying this is fx. This is the original one. This is the fundamental one. So x
Yeah.
increased by 1, fx increased by a factor of b. Increased by a factor of, which means you have the time of b, right? Does that make sense? Do you remember this?
No.
Okay, let me just present you this. I think eventually you will remember. Let me just give you an example.
I don't remember like learning that.
This is the fundamental exponential function. So a times b to x power. This is one of the fundamental things. Then x increased by 1.
No, yeah, I remember that. I just remember like the x increased by 1, so like factor.
When x increased by 1, so originally, let's just say original x is, well, x is x. So it increased by 1. Originally is fx equals to a to xb. And they increase by 1 is x plus 1, right? As a times x plus 1, right? See?
Yeah.
So what's the difference? It's using the original one, a, b to x power times a b, right?
Oh, yeah.
So that's why I can say I'm increasing. If you increase x by 1, I'm increasing the whole function fx by a factor of b. So you time a b. Does that make sense?
Yeah.
Yeah. The same thing here too. They said now they said increase because they use this is one of the things that you have to know. They asked this quite a
Yeah,
few
that makes
times.
sense to me. Yeah.
So now they also said increase by 1, right? They said increase by 1. But this is not in the standard form, right? That's where they mess up. That's messy. Because
Yeah,
that's
it's like
not original one. I
2.
want to
Oh,
make
wait. Okay. So if it's like, hang on, 2. We can still figure this out. A, B. So that's like, A, B, 2W times B to the power of 2. So, kind of.
Yeah, I'm actually using this way is also definitely working. We can also go to the original, which means I only want this form. Does it make sense? This form we are so familiar because most of the question is around this form. There are a few times like this, but I can change it back. How do I change it? I change it back by 0.829. I power that too, and then I might make it x power. Does it make sense?
Okay, yeah.
So, and then I can just say whatever that is. Now x increased by 1. What you increase? I should find that. Let me just find that. What's square? 0.829 squared. If you have calculator, you can use it too. Okay. So that is 0.687 to the x power. Is it the same or w power for this one, right? Is it the same thing, right? Does that make sense?
Yeah.
So now what does that mean? Which means you time a 0.687, right?
Yeah.
But when you time that, remember, this is decrease, right? So which means that's 1 minus p, right? Or p%.
Yeah.
So now my p is 1 minus that. Does that make sense?
Sorry,
Again,
beg your pardon.
keep.
How?
So
Why are these equal?
well, because I can say you time a 0. You decrease by a factor of 0.687, right? Does that make sense? I decrease.
Yeah, because it's like the original. Yeah, because
Yeah.
like the original times B to the power of 2 and B to the
Yes.
power of 2 is
I
0.
decrease by that. But they say this is by a factor, but they say it a different way. They said decrease by p%, right?
Oh, wait, yeah, that makes sense. So then that's like 1 minus P over 100. So P, oh yeah. Okay, yeah, I see.
Or you can just use decimal and then eventually change to the percentage. That also I will do it like that, but this way it's also working. Oh yeah, you're doing the way that I do. Good.
Okay, let me just.
But you have to do it completely. It's called p% is that.
Yeah, sorry. Mhm. Oh, D.
Okay. See, D. Yeah. So anyway, does it make sense a little?
Yeah, that does make sense. I think I get it.
So you probably have to like write this down.
Okay,
This
yeah,
one.
hang on. Let me just take like a screenshot. This is, yeah. Yeah, I see. I see like the logic behind it.
Yeah, you increase 1, you increase by a factor. Wait, where did I write that factor? It's called so fx increase or decrease, right? By a factor. of b, right?
Yeah.
Yeah, that's the fundamental thing about this kind of word problem for this. Sometimes they throw in more words as into a word problem, but still is testing this. I want to give you something else, because if this is a formula, I can say this is a formula, right? A times b to x power. This is a certain kind of formula, right? There is something else.
A times b to the x power. Okay, yeah.
There's a times b to the x over t, which is basically this one. This can be also recognized as something else.
A times, oh wait, I think I've seen that. So like how do you solve that? It's like there's so many variables.
Yeah, so let's use like for example, the interest in the banking system. They use this example quite a few times.
Oh yeah, it's like 1 equals wait, I'll just
Yes.
go to the bathroom really quickly. Sorry,
Sure.
sorry.
Go.
Yeah. Okay, I'm back.
Awesome. Okay, I mute myself. Now I'm okay. Now let's talk about a changed form for this a times b to x power. Let's say 4 months, I want to say every 4 months, I time a b. Does that make sense? Because
Oh,
my
wait,
interest.
yeah, that does make sense. I do,
So
sorry, I think I remember that.
yeah,
Yeah.
so now I'm going to change it. B, of course, my x is, how many months I have, divided by 4. So how many 4 months I have, so how many b I time. Does that make sense? How many 4 months I have, how many b I will time.
Yeah, that does make sense. Sorry. I
Okay?
think I get caught up sometimes in thinking about like, oh, what does being what's like with like variables, I guess. Like I get caught
Yeah.
up sometimes thinking about variables and I kind of forget like, oh, you can just
Yeah, so we write a formula like this, but actually t in the real question in SAT is just a constant number, right? It just tell you.
yeah. Yeah.
So you should put
I
this
think
two
a lot
together,
okay.
compare. Right?
We could move on to like another question. I think
Sure.
it's like more.
Yeah, so there's just this one you also have to write. These two together. And actually, let me just give you all three. This is the one, and then I go on. This is the x over t. There's a one which is a little different, but it's actually essentially the same, which includes something that we have in here. It's this, or p%, x or x over t. Yeah, there's three. They can have all of them in the test. Okay, let me go on. Next one is what? Next one is this, well, x squared minus c thing, the one that before that. X squared minus c, not this stuff. Okay, here is the ones before this. Is this one, right?
Yeah, I just didn't know how to like set it up, like how to use like the variables like to like set up the equation. Just
Yeah,
it's like
this is just well, let's just draw this and then you know. The labs are performed as students are seated at the lab table. If the teacher assigned 2 students to each lab table and 4 additional labs.
like I know we probably need to set up a system of equations. I just didn't really know like how to do
Yeah,
it.
draw it. Draw the picture is the first key for this. See, they said
Oh,
4 additional lab is needed, which means all the people just sitting in here. I need another 4 table, right?
yeah.
And this is the first situation. And the other situation, if it assign 4 students to each lab, and 4 table will not be used. Here, 4, so this is all the 2 students. So there's a 2 student in here, right? All of them, right? Which means there are 8 students left for the
Oh, so
situation
there's
1,
eight.
right?
Yeah, there's a way. There's like it's like two. Okay, wait. It's like
And for the second, this is situation 1. Second situation, they
two
say
L
4
plus
students.
2L plus 8 equals total like student number.
Yes.
Oh, and what's the second one?
The second one, they said now they say, let's say the second one is a 4 students for each lab table, and 4 will not be used. Which means there are, I have the minus, right? If I use 4 to time, you use L, let me use M, 4M.
4M?
Yeah, it was just saying we have M tables.
Oh, okay. I use like L for like the lab tables and like this
Oh,
S
I
for
thought I
student.
just used. Okay, so anyway, I use 4M. So I have a minus in the end if 4 is this not used. So I have 4 minus 16, right?
Wait, why is it minus 16? Oh, wait, because 4 times 4, right?
Because 4
Okay.
tables are not used.
4. Can we keep like the variables like consistent?
Sure.
Or yeah, so it's like L.
Okay.
Okay,
So now
so
they just can equal with each other, right?
yeah, hang on. Let me times 4. Okay, let me time 2 4L plus 16 equals 2S. 32?
Yeah. So 32? Okay, yeah, 32. Does that make sense?
Yeah, yeah. I think it's like, yeah, I think my problem was just that like I couldn't like I didn't draw like a picture, so it was just kind of like it was hard for me to visualize it
Yeah,
and then
yeah.
to set up the equation.
Just draw this. It's a certain type of question. They have this question several times. It's just that, we also have this kind of situation, right? How many, for the wedding or for this kind of thing, how many tables you need. It's actually quite the dilemma. We all just draw it. Basically, just try out kind of another way, right? Is that okay?
Yeah, yeah. It's like I think I just need to visualize it.
Yeah, draw a little, visualize it, and make the equation, and you can set it up, right? So next one. Let's see, okay, here, next one is,
So I really didn't know which was so blurry.
so that's the x value over a, okay, over a. Not this. Over a, this one. The function is defined by this. Ooh, that's blocking something. Minus 14, where a is negative, and what is the product? 15a, and well, we don't have much to do. We can just substitute for the moment. Is that okay? I don't think we
Yeah,
have a
it's just
lot
like
to do.
I got a result. I got a result, but like it was not 6 or 3A. So that's
Oh wait, the answer is there is not always right.
oh wait, it's not right?
It's not always right. They write all this because they made so many
Wait, can
mistakes
I
about
write what I actually got for my answer?
it.
You can't see it that well. Let me just rewrite it on here.
Hmm.
Because you can't, that's kind of blurry, so. Okay,
Oh, when you substitute, you have to kind of, don't you have, oh, are you being careful? A is negative, so the F's value isn't that negative 15a?
oh, right,
Mm.
okay, right, negative 15A?
Yeah. Everything else is fine. Just write negative in here, I think.
Okay, yeah. Oh, I think that's where I went wrong. Like, I didn't, A is negative, so negative, okay, yeah. So then, yeah, I think that's where I went wrong, actually, but I didn't know, but I forgot this bit.
Yeah. It's just that
Okay,
for F's value, for all the F's, whatever F's value, when you try to, not use it, you have to think about two situations, right?
yeah, sorry, I think I just kind of did it. I kind of just didn't read the A is lesser than 0, so that's why I was confused. Hang on, let me just do some multiplication really fast. Wait, no, this is just multiplication. Sorry, I misread that. Oh, yeah, that's good. Yeah, I think I just missed, like, I think I didn't read, like, this one bit that well, so that's why I got it wrong.
Yeah. So every time, right? The key is every time when you do something, or maybe sometimes complicated like this, but when you try to not use the F's value, so it's basically a piecewise function, right? You have to discuss situation 1 and situation 2, right? This just, they tell you just talk about one situation, right? Otherwise, I have to talk about when a is greater than 0, when a is less than 0, right? If not, I can't make sure, right? Because there are two situations.
Yeah, I think, like in that one, I forgot that A was less than 0, so I was just doing, like, 15A over A, and, like, so I got, like, 6 or something.
That's the beauty of absolute value. We get something from here to simplify a lot of things, but when we try to do it in a normal way, it's becoming like a piecewise two situation, two condition.
Hmm?
This
Oh
is
yeah,
the
I
next
struggle with
one.
this one. Yeah. I just it's like I tried to like set up like the equation, but I didn't really because there's like sorry,
Let me do it.
there's just hardly any like numbers
Yeah,
involved. It's
this is
kind
the
of
kind
hard
of
for me to
thing they
figure
don't
it
really
out.
have a pattern. You just have list whatever they gave you and see I can simplify or something. Say 4 to get in, so A to B's 4 over N is 5, right?
Yeah. So
And
then I try to
A,
do like
B,
log, so then I try to do a bunch of like
7,
log stuff.
X is 7, 7 over
But that didn't
N
really get me anywhere.
is 135. And what they want is 9 is basically A times B to X over 9, right?
No,
That
it's
means, oh,
9
actually,
over
9 over N. 9 over N. 9 over
okay.
N. And since they all have like a B and N thing, right? See, all three of them have B and N thing. I'm going to make them, a little bit separated. B, A, and it's B, 1 over N,
Oh.
right? And then it's ninth power, right? This one is A, B, 1 over N, and fourth power. Does that make sense? This one too. A, B,
Yeah.
1 over
Yeah, I
N,
think I see where you're going here. I
right?
just did like a bunch of log stuff I can really figure out. Oh, sorry.
Yeah. Substitution, right? B to 1 over N power happens so many times and it's complicated. We don't like it, right? We substitute. I can substitute as T, right? A, T, fourth power, right, is 5. And A, T, 7 power is, what's 7? 135. I think I can
And
find T, right?
okay, and then
Two variable, two equations, right? That's good to go. You can do like a division, like eliminate one, this elimination, right? You can add or subtract, and also divide. So A is gone, right?
oh
So that was just T to T cube, which is 135 over 5.
oh
Right?
right.
Division. Equation 1 divided by equation 2. That's actually kind of popular in SAT or in the future in physics too.
Oh yeah, 1/3, yeah.
Plus
You're fine.
2, 7. So T is
Yeah, sorry, just doing the okay, 20, so then 27 to the power of 2. Let me go on my calculator.
Wait, why power 2? It's like isn't that T
Because it's
cube?
like 3, because it's like
T is 3, right? T cube is 27 and T is 3.
oh,
Right?
yeah, I didn't need oh okay, yeah, I didn't need to do that. Sorry.
Yeah, it's fine.
Okay, so T equals 3, so then let's put it back in the equation. So
3 to the ninth power, right? But I
but
need
we still
A
don't know what
too,
A
right? Yeah.
is.
It's okay. We can find A, right? And we have a lot of, there's still system equation. I'm not finished because I can't
Oh,
find.
3 to the power of 4, A times.
That's a massive calculation.
A equals 5 over 81. Let me check with you. Okay, 135 over 2187. Okay, yeah, 5 over 81. Okay, so 5 over 81 times 3 power 9.
Yes, 1215. Nice.
Yeah, yeah, I think sometimes I just get caught up too much in like all like different variables. And I forget I can like
Yeah.
substitute and stuff.
We can summarize a little bit about this kind. They will give you, this is called massive calculation, too many variables. But remember, for example, this one, we still can't really find. There's the previous one also. For this, I can't find any more. Does that make sense? But I can use substitution, right? See? I don't have to know everything. Does that make sense?
Yeah, I think like I just get like with some of these questions I just get caught up like, oh my god, I need to know every single variable and there's so many variables.
Yeah, so remember, there will be something they don't ask you. And you probably can use simplifying if something pops out, right? This thing pops out again and again, right? Find a
Yeah, then
similar
just
thing, right?
substitute something for it. Like,
Yeah, substitution. And then the normal elimination or division, right? Oh, division is also something you can try. For this kind of division is also getting more and more popular these days. And in physics too, in SAT kind of too. Is this okay? It's a little
yeah.
similar as previous one. The previous one, remember the other one, we still can't find. The other one we use substitute a to c's power. We still can't find it in the end, but that's okay. We can find what they asked, right? Okay, let me see which one. This is okay, and this.
Just go to like the next one. Oh wait, actually 14 there's like a problem. 14.
Where is it? 14. Wait, 14. This one?
Yeah. 14, that's 15.
Oh, 14. Oh, that what's that?
I
Triangle.
answered, but like I didn't really I had some
Two
problems.
triangle thing. Okay, let me see. Two triangle. That's not. This is one?
14. No, not that
Oh,
one.
14. 14.
Sorry, these are all just organized really weirdly.
Yeah, this is actually collected from so many tests. Basically,
Yeah, I
at a
could
time is
tell.
all the tests.
Scroll up. 14.
Okay, I went through already. This? No.
Also, wait, for homework, do you want me to do like the rest of the packet?
How many questions you left? Do you have left?
I did like 40 something. I did like 25 pages.
25 pages.
There are 42 in total.
So yeah, finish the rest of it.
Okay, yeah, I'll just finish.
Yeah,
Yeah.
and then I
Oh,
will.
also I was gonna say it's 11:24. Do you have like another class after or?
No, I just go lunch. So let me just explain one thing. And then I will just remember there is also a SAT module 2, right? You can finish
Yeah,
that,
yeah, I
right?
remember.
Just 2 part. Okay, that's good. Where is that 14 that you said? Did we go?
I think it's up. Go up, go up.
It's a two
It's
triangle
like
thing.
two congruent triangles like A, B, C, and D, E, F.
Is this the one?
No, that's 27.
It's also not the one.
No, that's 12.
Oh, there's 14.
This one.
This one.
Yeah, it's just organized weirdly, sorry.
Triangle, it's okay. Triangle ABC is similar to triangle DEF. They're similar, and the length of each side, ABC is 1 times the length of the corresponding side DEF. The area of ABC is 40 square inches. Okay, so this involved with something. It's also kind of formula. Since we correct your mistakes, and I can give you a 4 formula next time. But I have to go over it in the class. Otherwise, I don't think you can get the full of it. So basically, it's this. This one is this, and the other one is this is ABC, and this is a smaller one. This DEF, right? So that's why it's 1 over 2
Yeah.
times that, right? DEF.
I tried to like do it, but it like I got
A
like
square.
frequently-
Say A1, area of 1, the ABC, and area of 2. Their ratio must be the length 1 and length 2. Does that make sense?
Yeah. Yeah, that
And
makes sense.
actually, no. Square.
Wait, why squared? Oh, because it's like length.
It's area.
Yeah.
It's
It's
area, right?
Right.
If you want to prove, I can prove. It's just, for example, you see every side is half it, which means your height is also half it. See that?
Yeah, that makes sense.
Half height and half the base, right? So that's why you should basically square that. Does that make sense? Whatever ratio you have, you should square that. Does that make sense? Does that make sense?
Yeah.
So whatever ratio you have. So this is a formula.
But like I was just gonna ask like but like if it's like the height, like it's like the length of like the sides are like is the height implied to be like 1/2 as well? Does the height follow the same ratio?
No, don't do that. I'm just proving that. But when you do it, remember there's L1, L2. It's just the corresponding size of any corresponding side because the ratio is the same. It doesn't really matter.
But isn't the area like height times 1, like for triangles, isn't the area like height?
Yeah, that's the proving because every side, the ratio is the same, so we don't have to worry. Does that make sense? If you think about a height, you have to think a little.
So it goes for that. So the height is also the same. Yeah.
Yeah. So this any ratio because you have the same ratio, but that's why we said same ratio for the length, right?
Yeah.
Same ratio for the length. So anyway, so that could be 1 over 2 square, right? Wait, let me think about it. Let me make sure it's right. The first one is 2. The second one, okay. The second one is the first one is greater. So actually,
yeah. So it's 2 over 1.
That's a 2 over 1, right? Yeah, this is good. 2 over 1, and then square that, right?
2. Yeah.
So that's a 4.
So it's like 4.
So A1 over A2 is 4. My A1, well, which one they tell me? A1 is 40, right? 40.
No, I think it's A2 that's 40, right? Because A1 is the greater one.
Well, I think they tells me ABC is 40.
Oh yeah. Sorry, I forgot which one was like the greater one. Never mind.
Yeah, that's
sorry.
why you should do in order. That's why I'm checking. It's a mistake. This we all made a mistake. So 40 over A2 is 4, right? This is do carefully. And well, there's a 40 times 4 and A2. So it's a 10, right? Oh, I can safely say it's 10. Does that make sense? Because A1 they tell me it's the area of the ABC, right?
We're finding the area of like triangle DEF. I thought
Which
like
is
I thought
A2.
ABC isn't ABC the smaller one?
ABC is the bigger one. You see, each side is 1 over 2 times. Wait, let me think about 1 over
Yeah,
2
it's like,
times.
isn't it the smaller one?
Oh, then you're right. Yeah, then I checked
Yeah,
wrong.
see, so it's
Yeah,
160.
the original is right. I should write a 1 over 2. 1 over
Yeah,
2.
exactly. Yeah, I'm
Yeah,
correct.
there. Yeah, good, good, good. And so that's a 40, and that's a A2, right? That's good.
Yeah, so it's
Great.
like,
I should double check. I actually use double check for this kind. When I do this kind, it's very easy to get, because I'm using a other first and second, right? Yeah, now how to heaven. Yes, 160, that'll be the right answer, right?
yeah.
Yeah, and use what you said, smaller and larger to check, right? Because you are the larger one, right? So that's why you are supposed to be the big one. Okay, does that make sense? And since we mentioned this is one of the formulas. Here's another one, which is V1 over V2. The volume for the similar shape is L1 over L2 cube. It's also in the syllabus, but they don't talk much.
Wait, volume is, oh, yeah. That makes sense.
That makes sense, right?
Yeah, that makes sense.
Square that and cube this, right? Yeah. Okay.
Yeah, it's like 11:30, maybe.
Yeah, sure. Let's stop here, and then just 2 parts of the homework, right? Okay.
Yeah, 2 parts homework. All right,
And-
thank you. Bye.
Yeah, and also we talk about a little bit that all formula sheet next time.
That's really helpful. Thank you.
Okay. Yeah. Hi. Bless you.
Bye.
Bye.